Welcome back. In this lesson, we're going to look at the bottom of the ocean. So we are going to find out if there's a hole in the bottom of the sea. So there's the topography of the ocean is as varied as the topography on the surface of the continents. So let's look. So topography, remember, is the ups and downs, the bumps and the dips. And so the topography of, say, a state or the topography of a country would be, where does it have its mountains? Where is its flat spots? Where do you have big lakes? Where do you have desert lands, and where do you have superabundant forests, etc.? The topography on the ocean is not that different. It is varied. You will have certain parts of the ocean that have very flat floors, full of sediment, piles and piles of, just long piles of sediment. So you'll also have deep trenches. You'll have mountains. You'll have ridges to where the crust is actually separating from each other. You'll have all kinds of different topography. It's just a little bit harder to find, a little bit harder to see. So we haven't, I'm sure, haven't mapped it completely, but it is as varied as the land around it. The major parts of the seafloor features that I'd like you to know is essentially where the continents are going to meet the ocean. So now remember, the ocean has a floor to it. So there is a crust that is underneath the oceans. It is thinner than the continental crust, because the continental crust is going to rise out over the oceans, so the continents stick out of the water, and the ocean floor is a crust also. And it's made out of two basic different materials. You're going to have basalt, which is that rock which is low silica content, high metallic content, and it's very runny when it's melted. And then the continents themselves are going to be made out of more granitic, thicker, higher silica content stuff. You're going to see that whenever that they encounter each other, one is going to actually slide under each other. We're going to talk about that when we get to the chapter on tectonics. But let's look at the actual features themselves. So you're going to have a margin, and that's the easiest idea. That's just where the continents end up at the ocean, at the beach. So where is the beach? That is the continental margin. And so what is the shape of Africa? That would be its margin. What's the shape of Australia? That's its margin, because it's going to encounter the ocean all the way around it. Now the continental shelf is rather flat and shallow. So right at the beach, you're not going to immediately drop into the deep ocean. You're going to go a while out on a rather shallow part of the ocean called the shelf. And every ocean is slightly different. So the Atlantic Ocean, for instance, can go a couple hundred miles of flat before it drops into the deep ocean. The Pacific Coast, because the Pacific Coast is actually slamming into the ocean, the crusts are actually touching and sliding under each other, you're only going to have a couple miles of flat before it immediately goes into a deep ocean. So that is called the shelf. So you have to remember that the shelf, let me go back, the shelf, if the water were lower, the shelf would be land. Okay, so the shelf would be the land. So if the water level would, say, drop, say during an ice age where lots of water is frozen into ice pack or glaciers, then that water would be lower and you would have more dry land. That dry land could be connected to, say, islands, or even one continent to another. The Bering Sea, which is between Alaska and Russia, during the ice age would have been the water would have been lower, and as a result there would have been a land bridge between the two continents. That's how it's believed that the Native Americans would have initially traveled to the Western Hemisphere over that land bridge. Then as the ice melted and the water levels rose, then that land bridge disappeared and the two continents were separated. Now the slope, let me go back again, the slope is going to just be that gentle area where lots of, I'll show you in a different picture in a second, lots of material is being dumped into the ocean from rivers, and then that is deposited on the edges of the continents. And so that slope essentially is the sliding rock pile of material, that debris that's come down off of the continents. The continental rise then would be a gentle rise from the bottom of the ocean up to the continental shelf. Okay, so you can see here that the continental rise essentially is lots of debris. And so it makes a gentle slope because it's so full of small pieces of particles in the mud and everything that came off of the down big rivers, or say into the ocean. And so as that material is being dragged into the ocean, you're going to get very heavy currents along the bottom. Those are called turbidity currents. Remember, turbid is anything where it's like muddy water, and turbidity currents will take that material that is from rivers and drag it to the bottom of the past the continental slope, and then you end up with a gentle rise. Then the abyssal plain, the abyss means as bottom as you can get, so the abyssal plain then would be the bottom of the ocean, the flat floor of the ocean. So that makes up the basin. So the basin is where the water is actually hanging out. So the basins are, remember, you've got about 71% of the Earth's surface covered in water. About 60% of that Earth's surface is covered up with these ocean basins. So you have the flat plains, that's just flat floor, and then you have very deep trenches. So a lot of times these trenches have to do with the fact that one plate that has maybe holding the ocean and one plate that's holding a crust of a continent is actually colliding, and one is being put underneath the other, and so you end up with deep cracks that go deep into the earth as these fault lines are present there. And so you end up with really, really deep parts of the ocean, much deeper than what you would think of as the normal ocean floor. So much of the deepest trenches have not been explored. So you can see oceanic trenches going down to 10,000 meters. That would crush a submarine. Submarines could not go 10,000 meters down without just the pressure of the water above it crushing it. So that's why it's problematic to try to explore all of this. Now, if you were to have a volcano under the water, then you end up with a vent. And sometimes the vent is simply just warm gases that are escaping, and sometimes it's actually volcanic lava that's coming out and creating new ground. So in the case of two plates that are shoving away from each other, it opens up a crack and then lava fills that crack, and so there's constantly new ground being made at the bottom of that crack in the ocean. Other times you actually have a hot spot that creates a volcano, and the volcano slowly builds land under the ocean and then eventually breaks the surface of the ocean. So that the vents, of course, have gases, many times toxic, noxious gases, but there are living things that very, very deep will live around the vent of a volcano, not because they're getting their energy from light, because there would be no light there at the bottom of the sea, but they're getting their energy chemically from the material that's in this vent. Okay, so if you have a volcano, eventually that material is going to continuously pile up until it breaks the ocean surface, and then you have an island. Those islands can then be eroded, and then you ended up being where the sea level is equal to the top of that, and that's called an atoll, and then it can actually go below, and then it's called a guyout, which is kind of an undersea ledge where lots of things can grow, reefs and such can grow on top of that. And then finally, you have these sediments. The sediments at the bottom of the ocean come from mostly rocks that are coming off of rivers that are on the crust that dump into the ocean, almost like a garbage dump where you just have a rock pile at the bottom. You can also have other sediments to where different currents can take, say, the volcanic ashes and stuff from undersea volcanoes and move those around. And then you could have material like sand that's broken up from granite and silicates from the crust, and it's dispersed at the bottom of the sea. And then you can have sediments that come from seashells that would like dissolve seashells, and then you can get sediments from just the chemistry that's going on in the ocean, where different chemicals that find each other in the water will become solids and settle to the bottom.